Hi, I'm Chelsea, and this is my implementation of the banker's algorithm for Project 3. This program simulates dynamic deadlock avoidance using a clean graph model. It reads system data, processes resource requests and releases, and it ensures the system remains in a safe state. This program begins by prompting the user to enter the number of processes and resources, followed by the total units of each resource, the maximum claims for each process, and the current allocation. So when a process requests resources, the program will check if the request is within the process's declared maximum, if there are enough resources available, and then if granting the request leaves the system in a safe state. To verify safety, I implemented the safe state method. It simulates the system after the request and checks if all processes can eventually finish. If the system becomes unsafe, then the request will be denied. Excuse me. I'm going to go ahead and run the program here and demonstrate a few commands. So let's say 3 processes, 2 resources, and do 10 and 5. So for this, we'll go ahead and do okay, and then for the allocation matrix, and okay, so here we see the claim matrix, the allocation matrix, the available resources. So now we're going to go ahead and request, and this request should be granted, but let's just be sure. Oops, excuse me. So here we are going to go ahead and have process 1 request 1 unit of resource 0. And the request is granted, and we see down here that this has changed from 2 to 3 because it requested 1 unit. And of course, this also changed because of that. Now let's go ahead and enter a request that should be denied. EST. So let's go ahead and do the so I'm so sorry. 2 0 6. So we're gonna have process 2 request 6 units of resource 0. This should leave the system unsafe and therefore be rejected. And there we see that it is rejected. Now let's go ahead and show the release command. So we'll release, and this should revert us back to what we were originally. And it went ahead and did that. And as we see, this is now 2 and this is 5 again. So this program successfully demonstrates the banker's algorithm by preventing unsafe resource allocations and avoiding deadlock. It uses a clean graph model, interactive commands, and a safety check to ensure system stability. So thank you so much for watching. I really appreciate it, and I hope you have a good night.